We're going to start this lesson off with the definition. And your definition of a one-to-one function is if any two different inputs in the domain correspond to two different outputs in the range. So I'm sure you are asking, okay, so what does that definition mean? Because I actually just read it and I said that can't be the right definition. Looked it up and it is word for word. So let's break down that definition. For it to be a one-to-one function, first and foremost, it must be a function. And so to remind you what a function is for every x value, there exists a unique y value, which meant no repeating x values, right? Our x couldn't cheat or repeat. And then it must pass the vertical line test, which is the VLT. So now that we have established it's a function, what a function means, for every y value, now there exists a unique x value. So now we can have no repeating y values as well. So nothing can repeat. And it must pass the horizontal line test or the HLT. So what is the horizontal line test? Very similar to the vertical. If every horizontal line intersects the graph of a function in at most one point, then the function is one-to-one. So example 1, determine whether the following functions are one-to-one. So we don't need to check the x values because it's already telling me it's a function. So I already know that there should be no repeating x values. Now, when I look at this one, we have our domain of guys. You can see that you have one line going from each of the guys. So it is a function. So to determine if it's a one-to-one function, we need to make sure that there's no repeating y values either. Well, there's only one arrow going to Carla and Deborah, but because Phoebe here is talking to both John and Chuck, that makes this not one-to-one. And you can abbreviate one-to-one with a 1-1. Okay, so same thing here. It's already a function, but if we look at the x's, we've got -3, -2, -1, 0, and 2. So our x's don't repeat here. So to make sure it's a one-to-one function, now I am paying attention to the y's. Do my y values ever repeat? We have 5, 3, 1, -1, and -3. So because none of them repeat, that makes this one yes, one-to-one. Okay, now for example 2, it says for each function, again, it's already established that the x's are not repeating. Use its graph to determine whether the function is one-to-one. So these are two of our key functions that were actually in the beginning, the first lesson in module 2. But if you don't remember what they look like, what can you do? Graph it. Okay. So the first one we have is f of x equals x squared. So if I was to roughly sketch its graph, hopefully we know that that is a parabola. And that shouldn't look as flat as mine does. That should be nice U-shaped, no horizontal lines there. And so we can again see it's a function. It passes the vertical line test, but does it pass the horizontal line test? And this one here is a no. It intersects the graph in two places. So this one is not one-to-one. This one isn't quite as common. So if you need to use your graph or your graphing calculator, you can. But this one kind of snakes like so. And so does this one pass the vertical line test? Yes. So it's a function. Okay, but it's really already told me it's a function, so we don't really need to check for that. But now, is it one-to-one, where anywhere I put a horizontal line, it's intersecting only once. So this one is yes, one-to-one. But again, if you don't know what these graphs look like, put them in your graphing calculator. And I also want to make a note of this one, that just because x cubed is a one-to-one function, not every cubic is a one-to-one function, right? So sometimes, let me get another little sticky note right here real quick. It's not uncommon for our cubic to look something like this right here. And so now when I put in a horizontal line, it intersects more than one. So not every cubic is one-to-one. So if it's not the most basic shape, you really need to put it into your graphing calculator and see what that shape looks like.